Hello, my name is Lisbeth Tejeda, and today I'll be discussing Session 13, SLF4, which is describe the contribution of each nephron segment to the reabsorption of the filter load of solutes and water. It's important to understand that every day the kidney filters about 180 liters of plasma, yet we only excrete about 1 to 2 liters of urine. This means that more than 99% of filtered water and solutes must be reabsorbed back into the body. This process occurs along different segments of the nephron, and each segment has a unique transport properties that determines what gets reabsorbed and what remains in the tubular fluid. Understanding where solutes and water reabsorb is essential for understanding the fluid balance and acid-base homeostasis. I'll walk through each nephron segment and explain how it contributes to reabsorption of the filter load. The proximal converted tubule is responsible for the majority of the reabsorption in the nephron. About 65 to 70% of the filtered sodium and water are reabsorbed here, along with nearly all the filtered glucose and amino acids. Bicarbonate, phosphate, potassium, and chloride are also reabsorbed in this segment. Important, the proximal tubule is highly permeable to water, so water follows solute reabsorption, keeping the tubular fluid isosonic to plasma. In addition to reabsorption, the proximal tubule secretes hydrogen ions and organic acid and bases, including many drugs. Because of this bulk reabsorption, the proximal tubule plays a major role in conserving essential nutrients and in maintaining volume balance. The loop of Hale establishes the osmotic gradient needed to concentrate urine. The descending limb is highly permeable to water, but not to solutes, so water leaves the tubule and the tubular fluid becomes increasingly concentrated as it moves deeper into the medulla. In contrast, the ascending limb, especially the thick ascending limb, is impermeable to water but actively reabsorbs sodium, potassium, and chloride. Because the solutes are removed without water, the tubular fluid becomes more dilute. Overall, about 25% of the filtered sodium chloride is reabsorbed in the loop of Hale. This countercurrent mechanism is essential for allowing the kidneys to produce either concentrated or diluted urine. The distal converted tubule is responsible for fine-tuning electrolyte balance rather than bulk reabsorption. About 5% of the filtered sodium chloride is reabsorbed here through the sodium chloride cotransporter. This segment is impermeable to water, which allows further dilution of the tubular fluid. The distal tubule also plays an important role in calcium reabsorption. Because relatively small changes in reabsorption occurs here, dysfunction in the distal tubule can still have significant effects on the blood pressure as well as the balance. The collecting duct is the final site where reabsorption is regulated. It determines the final volume and concentration of the urine. Unlike other segments, water permeability here is variable and depends on the presence of the antidiuretic hormone or ADH. When ADH is present, alkoporins are inserted into the membrane, allowing water to be reabsorbed. Principal cells reabsorb sodium under the influence of aldosterone or secrete potassium, while intercalated cells regulate acid-base balance by secreting hydrogen or bicarbonate ions. In the medullary collecting duct, urea reabsorption also contributes to maintaining the osmotic gradient. Overall, the collecting duct allows the kidneys to precisely adjust urine output based on the body's needs. Okay, now we're going to go into the NBME style question. Abby, a healthy adult, has normal renal function. Which segment of the nephron is responsible for reabsorbing the largest percentage of the filter load of sodium and water? I'll give you guys a couple of seconds. If you said C, proximal converted tubule, you are correct. Thank you so much for listening. Bye-bye.